All right. So that boron dash 10, that's the mass number, and we got to use that number to figure out our nucleus. So I'm going to get rid of this stuff. Kids just got to remember that, you guys. And so what I'm going to do, and I tell the kids, put your pens down, don't write what I'm about to write, because here, boron with a mass of 10. Kids, go to your periodic table. Somebody tell me how many protons boron has. Or we just, oh, that's right, everybody. We did it right up here. We don't have to go to our periodic tables. Boron, if I look in that first row, there it is right there. Boron has 5 protons. And so I'll just use that. You guys don't even have to do that. We already did the hard work. 10 minus 5 gives me 5 neutrons. So we could do this, kids. And again, pencils down, you guys. I don't want you writing this. I could do 5 protons, 5 neutrons. Beautiful. There, I'm done. There's my nucleus, because we know in the nucleus is protons and neutrons. I just did 5 protons. I just did 5 neutrons. Looks great. Well, that's all well and good, but what if I asked you guys to draw me Einsteinium? Oh my goodness, that's like 99 protons and 150 some neutrons. Do you want to put 99 protons and 99 neutrons? And there's no way I'm going to count all of those. So we're going to simplify things. Our nucleus is going to look just like this. 5 protons, 5 neutrons. Done. We don't have to make it any more complicated than that. Now, 5 protons equals 5 electrons. How many electrons can I put in the first energy level? I can only put 2. So what I'm going to do is I'm going to draw the first energy level, just a circle around it. And I'm going to put 2 electrons in there. And kids, I like to pair them together. I'll get to the explanation why I paired them together later. But that explanation is not for today. So I took care of 2. Well, since I took care of 2, that means there's 3 more. And I can't fit them in there because 2 is the maximum. So I have to draw the next level. And kids, I'm particular about how we do them. We've got 3 more. And so watch my numbering scheme. When we put these electrons in, we're going to kind of pair them up, because in the world of electrons, they kind of behave certain ways. So I'm going to put the numbers, because there can be 8 in here. 1, 2, 3, 4, 5, 6, 7, 8. So that's the order we're going to put those electrons in there. So it's kind of weird right now, but the explanation will come later. So I need to do 3 electrons. So there's 1 electron, there's 2 electrons, there's 3 electrons. So I've spaced them around, and we're going to get to why that is. But remember, that's for a later date. So please, for now, just work with me, and that's how we do it. We'll do fluorine in a second, where we'll see some more electrons. And so I'm going to get rid of those numbers. We don't need those. And so that's what an atom of boron with a mass of 10 would look like. It has 5 protons in the nucleus, 5 neutrons in the nucleus, and then the electrons are properly placed in the electron cloud. Then, Allie, sorry, a lot of that I talked to you. That's how I would do it with the kids. Okay, kids, let's get boron 11 for now. Let's slide down to fluorine 19. And so, again, I'll move through this one a little quicker. Starters, I always put these in the side just so the kids start to remember them. And then I remind them this is mass number. That is not the atomic number. Fluorine, I need the number of protons and atomic number of 9. So again, I'm doing all this for them so they can see my logic. And so now I know the nucleus, 9 protons. Again, I'm just kind of speeding this one up for you. So I've got that. So 9 protons equals 9 electrons, and so I'm going to start my energy levels. I always pair up the first 2. 1, 2. Well, if there's 9, I just took care of 2 of them. That means I have 7 more. And I'll do this one more time for the kids. Remember the order: 1, 2, 3, 4, 5, 6, 7, 8. That's the order that we fill the electrons in the outermost energy level. And so I have a total of 7. So I would go 1, 2, 3, 4, Now I'll start to pair them up 5, 6, 7. And so I follow that kind of numerical pattern. Some teachers, you guys in the building, do it different ways, and that's totally okay. But this is how I like to do it in my classroom. And again, just bear with me, explanation will come later. So if I get rid of the stuff that I don't need, that's what fluorine with a mass of 19 would look like. Now, kids, on your own, draw me boron with a mass of 11 and draw me boron with, fluorine with a mass of 18. And that's where I'd let them loose. I try to just give them to the end of class to do that, depending on more timing wise. And you can just work it from there. But that's kind of that introduction to how to draw the diagrams.